Hello, this is the Arduino Shield Kit we'll be building in class. This is what the circuit diagram looked like, so just so you've got an idea of what these look like. You'll notice that there's 6 of these round circles with a bunch of stuff in it. Those are the Mosfets. And after that stage in designing that circuit board, it looked like this, and it's kind of a puzzle. You got to untangle things. And after it gets all untangled, the design looks like this, and this is essentially what gets sent to the circuit board manufacturing company, and they produce the circuit board from it. It's a bunch of screen printing processes, and then etching and hole drilling. This is a mock-up of what the back side of the board looks like. Finished. And before I sent that off, I built boards like it on a variety of different prototyping boards. This first one on the upper left has got no copper on it at all, so you can stick components through there, but you have to solder them together with wires. The one on the upper right is a little bit better because you can solder things in place, because they have these little circles of copper on the board. This one here is set up just like your wireless breadboard. The 2 buses down each of the sides, and then all of these things in a valley down the center. And this is a shield, and it's set up so that when you get done, it'll plug right into the top of your Arduino. But it's a prototyping board, so you can build a circuit on top of it. These are the backs of all the boards, and the prototyping board has got solder circles on the back side so that things will stick on both sides of the boards. And the best boards have that. There are a few times when maybe you don't want that on the back of the board, but usually you do. So this is a cheap board here. This is even cheaper. In your kits, and when we stop, I'll turn back to this slide. You want to make sure that you have all the parts. And anytime you buy a kit, that's the first thing that should happen. Did all the parts come with it? And some kits can be have a lot of parts. So you need to be careful checking things off. This little 2-port thing right here has got screw terminals on the end, and it's our power connector. And this one has all the outputs of this board. So if you want to run a bunch of LEDs, this is where half of them get connected up to, and the other half gets connected to the positive side, plus voltage, VCC. These are pull-down resistors for the Mosfets, and we'll explain what those do, but not today. And this is the LED ballast resistor like we've been using with our LEDs. There's the LED. These are called flyback diodes. These are really just diodes, but we're using them as flyback diodes. And this is a USB connector that we can stick wires in the end of and use the screws to connect them down. These are the connectors that will go through the board to allow you to connect it to your Arduino, and also allow you to put wires in the top if you want to hook something up somewhere else. Here's the circuit board, headers, and these are the Mosfets, and I wrote the number in there. They try to make these numbers have meaning, but mostly they don't for me. But this stands for 60 volts, and the L means it can be controlled with a logic level voltage. Our Arduinos put out 5 volts, and that's logic level for our Arduino, so they're kind of compatible with that. Here's our resistors. This is brown, black, orange. And if you remember, a brown is a 1, a black is a 0, and orange is 3 more zeros. So there's 1 0 and then 4. This is 10,000 ohms. This last one, the gold here, tells you how accurate the diode is, how close it is to the rated ohms, rated resistance. This one here is orange, which is 3. Brown is 1, red is 2, orange is 3. Then there's black and brown. And so this is 3 O and then one more 0, O, 300 ohms. And that is the ballast resistor for this light emitting diode or LED. And here is the printed shield. And you know, the nice thing about this is that it tells you what most of the stuff is. There are a few places where I missed things, but this says 10K ohms and it's labeled R6. R is a resistor, 10K ohms, that's the value, so you can stuff those real easy. You don't need to look at something. And then these say Mosfets on them. And these are diodes, and these little lines here and these lines right here show you which way to put these components in, because you can put them in, you could put them in backwards, they won't work. Here is R7, it's a different value. It doesn't say ohms after it, but it says 1K, and with this R, you pretty much know it's a diode. This does not say which side is which, and that's unfortunate. And so we'll get to that later as we're soldering things up. Here is the board with all our resistors stuffed in there. And when I'm stuffing resistors, I goofed this one up, but I like to have them all facing the same way. So if I need to check, it's easier to see whether or not I've made a mistake. And when I put a resistor in, I bend the leads over on the back side, unless the board is really, really tight. This is a good practice. It holds the resistors in while you solder them. Makes the whole thing easier. And here it is after I soldered and I'm inspecting. And I'm learning to inspect things with a camera, because when I use a camera I can blow it up and then see things like this little hole here. This was bad, and it looks like this one might be bad, but it's not. Here it is a little bit bigger with a circle around it. I can see that there's a problem there. Another way to check is to go to the other side of the board and see if the solder came through. The other side of the board looks good and the solder is beaded up against the flowed into the wire here, come through and float into the wire, then it's a good connection regardless of what the other side looks like. But right here there looks to be a problem. Here it is a little bit bigger. You can see that that wire is not attached. And so I want to make sure I look at the other side of the board and make sure it looks good, or just get a soldering iron in there and heat that up until it flows together. These are diodes, and you can stick them in the wrong way and they won't work. Or they'll burn out your board, or they'll burn out your Arduino. There's something worth being very careful with. So these lines here on one side of the diode tell us which way to put them in. So here's two diodes stuffed in the boards, and if you look you can see the line is on this side, and on the board the printing has got a line on the same side of the diode. And so there's everything, all those things stuffed and soldered, and these headers stuck in. It's really important that you put this headers in properly, that this header has got 2 spaces at the end, and this header has got 2 spaces in the end, and all the other holes in the headers are filled up. or something's not going to work right. This is one of my spare boards. It's nice to have a board that has the headers soldered on and have them working, because then you can flip your new board upside down on it and have all your headers lined up and not wiggly, so that they fit into your Arduino real well. And while I was doing this, I noticed that there was a lead here that I failed to solder. So it's definitely possible to miss solder joints. Here I am stuffing the MOSFET, and if you look, it's got a metal part on the back, and it has, this is the heat sink, and it has this line here. So the holes are there. The heat sink goes lined up with this, not turned around. This and this part of the diagram get lined up. If you put it in backwards, it's going to burn components, and it's likely it won't work. It won't work, and something's going to burn out. And this is the back of the board all finished. And it's important when you put these screw connectors on to make sure that the holes that the wires go into are facing out and not in. It's really easy for me anyways to do it in the opposite direction.